So, good morning. How are you doing? It feels really great to speak here at Rubyfuza. I really liked yesterday, the talks were great, and I'm sure today will also be great. So, I'm the first one today. I hope you'll get a good time today and learn a lot from the talks. So, let me introduce myself. My name is Ruan Brandão. I'm a software engineer at Magnetis. We're an investment fintech based in Brazil, and we are hiring. If you want to know more, and if you're interested, you can come talk to me later. And my friends also describe me as a Twitter timeline curator. They say I'm great at browsing Twitter, finding interesting things, and retweeting them. So I feel like that's a talent for me. If you want to find me at Twitter or at GitHub, you can use those handles. And I am from Brazil. I think it is a great place. It has lots of different stuff and unique stuff. And I decided to show some landscapes from Brazil so you can see a little bit of what I see every day. This is the landscape that I see from the Magnet's office at São Paulo. But we have a remote team, and I asked some of my teammates to send me pictures from where they live. So here's a picture from Paulínia, a countryside town. Another one from Pipa, from Rio Grande do Norte. But Brazil is not just landscapes. We also have great tech in Brazil, and in fact, Elixir is a Brazilian programming language. It was made and created by a Brazilian programmer, José Valim. It was sponsored by Plataforma Tech, a Brazilian company. And even though Brazil has great, unique things, we also have things that are not so great and also happen in the whole world. And one of those things are cyber attacks. In Brazil, they happen, and they happen not only in Brazil, they happen in the whole world. They are, unfortunately, they're very common. You see in the news a lot of cases of stolen data, of exposed sensible data, and it's kind of difficult to maintain our web application secure because this is the entry point that attackers use to exploit these vulnerabilities and get the sensible data or attack our systems the way they want. So my talk is a field guide for web vulnerabilities so you can get to know a little bit more about them and how to protect your systems from attackers. And to start, I want to talk about the web. The web is a great platform. It runs almost everywhere. You can run a lot of different things on it, but the web is just not one monolithic piece of tech. It is a combination of various different technologies. Some of them are a little older, some of them are new, and they all work together to make the web as the platform we know today. And by its own nature of being very different parts working together, the web has a few things that can be easily exploited by attackers to get sensible data or to attack an web application. So getting to know the web and those common points where attackers can get in your application is very important. So I've got some of the most common vulnerabilities in web application, and I'm going to explain them and show how you can protect from them. The first one, and one of the most common and dangerous, is using components with known vulnerabilities. Nowadays, web applications are somewhat complex. And when we're going to build a new software application, we don't want to write everything from scratch. We're going to use frameworks, we're going to use libraries, we're going to use gems. And when we do that, it is great because we can get a lot of common logic that is already done and just use it on our applications. But if one of those components have a known vulnerability, we're just putting that vulnerable code inside our application. So our application also has this vulnerability. So I got a simple example about using a component with the known vulnerability. Rails 4.2.2 is kind of a node version of Rails. It is known that it has a lot of vulnerabilities that they have already been fixed, but only on later versions. If you're running Rails 4.2.2, then your application is vulnerable. And this is a big problem because you have a vulnerability in your system, and because since this vulnerability on this library or framework or gem or dependency is known, if an attacker discovers that you're using this vulnerable version, very probably they also know how to attack your system because the vulnerability is known, so probably exploits for this vulnerability are already out there. So my first security tip is always remember to update your application dependencies. It's not an easy job much times, especially when you're dealing with framework updates or major versions updates from gems or libraries, but it is very important because we're bringing third-party code to our applications, and if this code is vulnerable, that is a problem. And it is a very common issue, but it's not that hard to protect from it. The next kind of vulnerability I'm going to show is injection type of vulnerabilities. There's not just one kind of injection vulnerability, but lots of them, like they're listed there. Those 4 are just 4 examples. There are more than that. And injection vulnerabilities, basically they allow attackers to run code where they shouldn't do it. The most common type allow attackers to run code or comments on your application servers. One of the most common and known kind of injection vulnerability is SQL injection. And I'm going to focus on how to solve these vulnerabilities with Rails, but I'm going to explain how to solve it in a more general way. So if you're using other framework, you can get to know what it is. And there's a very good XKCD cartoon that explains what SQL injection is. And it's like that. Today, web applications, especially complex web applications, have to deal with data, and this data is stored on a database, and the application has to store data, update data, fetch data from the database, and the application also has to get input from users. But sometimes a user where it's going to input something in the application, instead of putting valid data, the user can put a valid SQL statement. And if the application doesn't deal with the data well, the SQL statement will run on the database. And depending on the statement, this can do lots of bad things. This can drop database records like it shows on the cartoon. It can show sensible data to attackers, and etc. And the way we can protect against SQL injection is to escape every input that we're going to receive from the user and then run on the database. And escaping this data is like, instead of using valid SQL characters like a semicolon, for example, we use a different representation. So if you're printing this data on a screen, it will print OK. But if you put this data on the database, it won't be interpreted as a valid statement, but just as a string data. And this first example is an example of how you should not do word queries on active record. In this first example, I'm using string interpolation to get params that I'm receiving from a web request and creating a string that I'm going to put on the database. If we do things this way on where from active record, then this data won't be escaped, and if a user puts a valid SQL statement, it's going to be run on the database, and things can get ugly. And we have two very good alternatives if we have to do that. Those, those are here. The first one, we can use question marks on our string that's going to our database. And after that, we can pass other arguments, and they're going to replace these question marks in order. So like params name will be on the place of the first question mark, and params email will be on the second. And we have also another example in the last line where we can name those parameters on our SQL string. It's not really interpolation. We're just using a colon and a name we can choose. I chose email and name here. And as a second argument, we can pass a hash. And in this hash, our keys must have the same names we've put in our string. And those values are going to replace it on the string. And when we do those two good alternatives, Rails will escape this data from us automatically. So just by doing that, we're like protecting ourselves from SQL injection when using where. And other very common mistake that I've had to deal before is with the order method. And we have to be very careful with order because the order method won't escape what you pass as an argument for it. So I already had to do a security check on the system, and we had like 50 different places where we got params from the request and use it for order. And so there were 50 different places where we were vulnerable to SQL injections. And a good thing we can do is use a list of allowed parameters for this word, like in the second example. So we'll first check if the parameter was one of the valid database fields we want to order. And if it is, then we can pass it to order method. And if it's not, we shouldn't do it, because if we're doing it, we're exposing our system to SQL injection. And other two similar types of injection are code injection and command injection. So SQL injection is about database statements, and code injection is about an attacker running Ruby code on our servers or whatever other backend code language we're using. And command injection is when an attacker can run an OS command in our servers. So two really bad examples are those. Eval takes a string parameter and reads this as Ruby code and executes it. So if we're calling eval on anything that a user has put in our systems, then we are running whatever code someone from outside is putting in our systems, and that's very, very dangerous. The same things with backticks that does the same thing, but with OS comments. So if you do that, we're doing that, an attacker can run chmod, can run pwd, and depending on what you do, it can see sensible data, can run cat on files, etc. And another tricky example is with constantize, because when we use constantize, Ruby will get a string that we pass to constantize and transform it into a known constant on our system. So if a string we pass is not a constant on our system, like it does not begin with a capital letter, it's not a constant, constantize won't do anything. But imagine if this params class, instead being a user or a guest user, were like a credit card constant. It would instantiate a new object that we're not dealing with it correctly, and it can pass methods to the wrong objects, and then things can get ugly. Another interesting type of injection is cross-site scripting. So those injection vulnerabilities I mentioned allow attackers to run code on servers, and cross-site scripting allow attackers to run code on your application users' browsers. So one example, imagine you have like a text input where someone can put something like a block comment, for example, and when they send it, it's going to be loaded by other users on their browsers and etc. And instead of just writing a common comment, someone can do that and write valid JavaScript code on this input. And if we do not escape this kind of input, when some other person loads this page, this JavaScript code is going to run. And in this example, it's just an alert, but it can be any kind of valid JavaScript code, and that's a very, very dangerous thing. So how we can do this and protect from this here is similar to how we can protect from SQL injection, and we should escape whatever input we receive from users, and that is going to be loaded on the screen for other users. So the good thing is Rail does this hard work for us. If we get a string that is valid JavaScript code and just render it on ERB, it will be escaped by default. But there are two dangerous methods, and those methods are raw and HTML safe. Especially HTML safe because its name is misleading. The first time I saw HTML safe, I thought, okay, I want this string to be safe, so I'm going to call HTML safe on it, but that's wrong. In fact, when you're calling HTML safe, you're like saying to Rails, don't escape the string because I am ensuring that it is safe. So if you take user input and call HTML safe on it, Rails won't escape like it does by default, and then you're being vulnerable to cross-site scripting. And raw does kind of the same thing. There are a little bit differences between raw and HTML safe, but for this specific case, we can treat them like doing the same thing. So this brings us to the second security tip I have, and that is never trust user input. I don't want to fall on the cliche that's saying that users are dumb and they don't know how to use our systems. No, I'm not saying that. Users are essential. If there were no users, software would be useless and I wouldn't have a job as a software engineer. But when we say users, we're saying everyone that is external to our system. And this can be a user that just wants to get the value that our software is proposing to them, but that can be an attacker. We have no way of knowing. So we should never trust input from users because it can be valid data, but it also can be an attacker trying to invade our system. So whenever we're dealing with user input, we should be extra careful of what we do with it so we don't compromise our applications. Another kind of vulnerability is, broken access control. So imagine this. Imagine that we have an endpoint on an application that takes a user ID and like logs this user somehow, and it also takes a credit card ID to do something with it, maybe a transaction, maybe update this credit card data, whatever. But it is an endpoint, so it can receive valid data, but the person sending it can also send a different data, like use a user ID, but use the other credit card ID that the attacker is just guessing. And if we fetch this credit card from the database like this, just getting what we received from the request and using it to fetch the data from the bank, it can work okay, but we also can get a credit card that does not belong to this user and maybe run a transaction on another person's credit card. And this is not a made-up example. This actually happened in Brazil a few years ago on a great system, this exact example. And the attacker that showed this as a responsible disclosure after it was already corrected said that when it did that, this credit card with the ID number 1 was the credit card of the company CEO. And it actually ran a transaction using the company CEO credit card. So this is a kind of harder problem because it does not deal with the web as a platform and its vulnerabilities, but it's more of a design flaw. So in this case, we could make this. Instead of searching from all records on the database, we just should search only the credit cards that belong to the logged user. So with a simple modification, we can protect ourselves from this kind of vulnerability happen. So this is my third tip. Be very, very careful with access to sensible data. Whenever you are designing your software system, you must always think what data is really sensible and who should have access to that. And you will have to make sure that only the people that should have access to that can see this information. And it's also very important that we do it on the back end, because front-end validation is great. You should always use it when possible, but it's very easy to disable front-end validation. An attacker can simply disable JavaScript on the browser or use curl to make a request to our system, and like that, all front-end validation is gone. And if we also don't validate things on the back end, we're going to be very easy targets for attackers. And another popular kind of problem is broken authentication. And this is mostly because authentication is hard. It's a very hard problem. It's very difficult to make a really good, resilient authentication system from scratch. So my tip for it is, unless you know very, 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 very well what you're doing, and you have a very specific case where you need a different authentication, don't try to reinvent the wheel, because authentication is a very sensible part of an application, and one problem there can compromise the whole system. So unless you have a very specific need or know very well what you're doing and have a team with a lot of devs that know a lot about security, don't try to reinvent the wheel and go with battle-tested solutions. And besides those kinds of vulnerabilities I show here, there are many, 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 many more. I could talk the whole day and would still not be done. And given the scenario, we can think how we can protect from all those kinds of things. And it's not easy, but it's also not that hard. One thing we can do is research and study how to protect ourselves. And the single greatest resource I can indicate to you is OWASP, the Open Web Application Security Project. It's a project that is maintained by the community, and they have lots of information on vulnerabilities, not only on web, but on desktop, mobile, etc. And every year, they make a top 10 with the most popular application security risks that year. The 2018 version is still not ready, but this is the most recent from 2017. And these are the top 10 most common vulnerabilities in web applications. And if you want to start from somewhere, check this top 10, the latest one, see the 10 vulnerabilities, try to understand them and protect your system from them. It is a great start, and it's a much more than many other softwares we have out there. But we don't have to trust only on your memories, and we can use tools for that. And there are three kind of techniques we can use to protect ourselves from that. The first one are static code analysis tools. So for example, let's say we have one of those bad examples I've mentioned earlier. We don't have to remember that it's a bad example. We can use a tool to just show us that. So you can just focus on fixing the problem and not trying to remember what the problem is and how to find it. And one great tool for that is Brakeman. It is still an open source tool. It's very good. It is a command line interface. You run Brakeman on your Rails app. It will generate a report for you with all the possible vulnerabilities. But you can also use different tools like CodeClimate and Ebert. They're both vulnerabilities they're both tools that use Brakeman under the hood. And they just have different interfaces. Like CodeClimate is very popular. You can see all the possible vulnerabilities in a web interface. And Ebert has a really great feature that I like, that it can comment on your pull requests. So whenever you do a pull request, if you have Ebert configured, it'll run not just Brakeman, but other linting things, Robocop, etc. And if you have a security problem, you can see that on a pull request and correct that before it hits production. And there is other great tool from GitHub that if your repository is on GitHub and is in one of the supported languages, and Ruby is one of them, it is going to check your dependency tree. For Ruby, it'll check your gemfile.lock file, and it will look for vulnerable dependency versions. And if you have a vulnerable dependency, a vulnerable gem, it will tell you and say, oh, this gem has a vulnerability in this version, update to this other version where this is corrected. So this is very, very good. And if you're using GitHub, you just have this tool. You just need to configure it and use it. But you can go further and use security scanners, because static analysis tools, they're going to check check for problems on your code, but they won't run your code. They'll only analyze it statically. But you can use scanners that are going to interact with your system and check the system response, or if the system goes down with a particular request, and etc. And it will generate a much more detailed report with these vulnerabilities. It really tests against your system. The confidence is higher, the number of false positives is lower. And one good security scanner is Arachne. It is an open source project. It is written in Ruby. So you can just download this project. You will also have a command line interface, and you can just pass the options like your application URL. If you're going to do that on an application, I recommend testing against staging instead of production, since it can bring your application down depending on the problem you have. And it takes a lot more time for running. So it has to test against lots of types of attacks, but it really gives you a better result. And one other technique that is really the best technique, but it's also the most expensive, is using penetration tests. And this technique consists of hiring a professional open tester who really knows how to attack systems, and this professional will try to attack your software and then make a report of every vulnerability you have. So in this kind of technique, you have a really, really high confidence report of vulnerabilities, because if this gave a positive, it means that an actual human being attacked your system and got sensible data, or brought your system down, or whatever. But it is expensive. You have to find and hire a good professional to do that. So it's not so scalable. It's not a thing you will run on every pull request like Ebert, but it's good to do that for security critical systems. And to finish, I want to give the most important security tip of all. The security tip number 0 is that security is not a product that you buy and you're safe for life. It's not a task you can finish. It's not something that you will see and then think, okay, my application is secure now, I'll never have to think about it. Security is a process. It's an ongoing process, and it doesn't end. So when you're trying to make your application secure, the best thing you can do is think about security when you're designing your software, when you're deploying your software, when you're reviewing your software, and when you're writing your software. Because I like to use this comparison that whenever you leave your home, if no one is there, you have to lock the door, because if the door is open, someone can enter your house and steal your things. No matter how many times you've locked your door before, if you leave the door open one time, you're vulnerable to someone entering in your house and stealing your stuff. And with web application security, it's kind of the same. It doesn't matter how many effort you've put in making an application secure before. If you put new code or a new vulnerability is discovered on a gem you use, then you're vulnerable and you have to fix that. So think of security as a process, as an ongoing process that will never end and that it has to be applied on your software development process. And that's it. Thank you.